All right, so most of us have probably played around with op amps, right? We know they can do this neat little trick of adding voltages together. But what about the other side of the coin? Today, we're diving into its powerful counterpart, subtraction. And you'll see how finding the difference between two signals is honestly a fundamental tool in pretty much all of electronics.
Okay, so let's just put these two side by side for a second. On one hand, you've got the op-amp adder. You put in V1 and V2, you get V1 times V2 out. Simple enough. But our focus today, it's the subtractor, sometimes called a difference amplifier. Look at the formula. It's practically the same, just one little minus sign. But that one tiny change, whoa, it unlocks a completely different universe of possibilities.
And that brings up a really good question, right? I mean, in a world where we're always trying to combine things to add stuff up, why on earth would you ever need to subtract one signal from another? Like, what's the point? What problem does that actually solve? Well, as it turns out, the answer is everywhere. Yeah, this isn't just some abstract thing we do for fun in a lab. In the real world of electronics, finding the difference is how we make sense of everything. It's how we take messy real-world information, like comparing two different signals, and turn it into one single, clear command that a system can actually understand and act on. And the places where this pops up, they're everywhere, and they're super diverse. Think about it. You can use subtraction to measure a tiny, tiny difference in temperature between two sensors. Or how about this? You can use it to cancel out annoying background noise in an audio signal. It's even used to guide the super precise movements of industrial robots. See the pattern? In every single one of these cases, the difference is the key piece of information we're after. So how do we actually do it? How does the circuit work? Well, let's meet the tool for the job. It's a special circuit called the op-amp subtractor. Or, if you want to get a little more formal, the difference amplifier. Okay, so what is a difference amplifier? Well, at its core, it does exactly what the name says. It takes two input voltages, finds the difference between them, and spits that out as an output voltage. But here's the really cool part. The circuit can also amplify that difference. It has a gain factor. So you can take a super tiny, almost invisible difference and blow it up, make it bigger so that the rest of the system can actually see it and do something about it. It's like a magnifying glass for voltage differences. All right, full disclosure. When you first look at the schematic for one of these, it can look a little intimidating. There are resistors all over the place. But don't worry about that just yet. Seriously, let's just push all that complexity to the side for a moment and focus on what's actually happening. Because the principle behind it is incredibly simple. Let's just break it down into a few simple steps. First, our input voltage, V1, comes into the circuit. Then, our second input, V2, arrives. Now the op-amp, which is basically the brain of this whole operation, it does its thing. It looks at both of those inputs and performs the subtraction. And finally, boom! The output is a single voltage that represents the difference, V2 minus V1. That's it. Simple as that. Okay, enough with the theory. Let's see how subtraction works in the real world. And we're going to use a super practical example, something you might even have in your house right now, a temperature control system. So check this out. In something like a thermostat, you've got two key pieces of information. Let's say sensor 1 is measuring the actual temperature in the room. And sensor 2, that's your set point, the temperature you want it to be. The difference amplifier is constantly, and I mean constantly, comparing these two. If the room is too cold, the output voltage goes positive, and that tells the heater to kick on. If the room gets too warm, the output swings negative, telling the air conditioner to start up. It's a constant balancing act. And this is the magic right here. You take all that information, two different temperatures, which could be fluctuating, and the circuit boils it all down to one single number, 1 voltage. In this case, maybe it's positive 2 volts. That one value is the signal. It's the clear, no-nonsense command the system needs to do its job. It's the exact moment that raw data gets turned into a real decision. So you see, learning about this circuit isn't just about memorizing a schematic. It's about unlocking a whole new power for your projects. This is the power of difference. You now have a tool that lets you compare things, measure against a goal, and build systems that can actually react to the world around them. So really, the big takeaway here is this. Just like op amps can add voltages, they can also subtract them. And that opens up a ton of new possibilities for whatever you're building. Think of it like this. Addition and subtraction are the two pillars of working with signals. Once you've got both down, you can not only combine signals, but you can also compare them. And that's the secret sauce behind pretty much every feedback and control system out there. So I'll leave you with this final thought. You now understand the building blocks. You have the power to combine signals, and you have the power to find the difference between them. So now that you can both add and subtract signals, what problem are you going to solve first?